So here we've got some very small numbers, and we're asked to write these numbers in decimal notation. So we'll just start with, I'll just pick a few. Let's say I'll do B, and I might do K. So question 4B, I write down the question. 4 times 10 to the power negative 3. So this has no decimal point, so let's put it in. And because it's negative, we know that the final number, the actual decimal number, is a number less than 1. So that means to make this actually smaller, actually I need to give myself a bit more room here. Just get my eraser and try again. I'll put the 4 here, so I get 4.0. I need to, the negative means we need to move the decimal point. When 10 to the power negative 3 is effectively dividing by 10 3 times. So if you divide 4 by 10, decimal point moves to there and you get 0.4. And then you divide by another 10 and you put a 0 and you get 0.04. And then you divide by another 10, put another 0 in, and put a decimal point there, and you stop. You've done it 3 times. So the final answer is here, you get 0. I'll put a 0 before the decimal point. That's the convention. Normally you don't just leave it dot, decimal point 004. So we have 0.004. Effectively that's 4 thousandths. 4 thousandths, that's what that is. So, and that's true. 10 to the power of negative 3 is 1 over 10 cubed, and 10 cubed is 1 over 1,000. So effectively what you got there is 4 times 1,000. So you got 4 1,000ths. Let's try another one. Squiggly line, K. We got 2.625 times 10 to the power of negative 9. Now I'm going to need a lot of room here, so I'll put the number right over here somewhere. The original number, 2.625. And I get my pen. And now, essentially, because it's negative, I've got to divide by 10. 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I eventually fit them all in. So let's write out the actual nice neat answer. We get 0.3 zeros, another 3 zeros, then 2 zeros and a 2. Notice then, and then I write the rest of the number, 2625. So negative 9, essentially, I did this example before, 10 to the power of negative 9 is essentially 1 over 1 billion. So what you have there is you have about 2.625 billionths, and that's the original number down the bottom. Okay, so let's rule those ones off. Let's do a couple where we do convert from decimal form to scientific notation. Let me choose, I'll do E, and I know, doesn't really matter, I'll do C. So let's start with question 5, E. We've got 0.231. So here, when we're going from scientific decimal form to scientific notation, we want to move the decimal point to the right. So to do that, you have to multiply by 10. And every time you multiply by 10, we're going to have to then divide back by that to get a number that's equivalent. So here, I'm going to move the decimal point 1 spot to get it between the 2 and the 3. So that leaves me 2.3, which is what we want, 1. That's now scientific notation. The first part is in scientific notation, and I'm between 1 and 10. And effectively I need to divide this by 10, and dividing by 10 is 10 to the power of negative 1. Okay, we'll do one more. I'm going to do C. My lettering's I'm a bit out of order there, aren't I? Anyway, 0.3 zeros, another 3 zeros, and now a 3. So I'll just write the question, and so effectively I'm going to times by 10, times by another 10, so that's 100, 1,000, so it's 10 cubed, 10,000, 100,000, a million, 10 million to get the decimal point there. So that's sort of our working step. So let's write down 3.0, or you can just write 3 times by. So effectively multiplied by 10 million. To get this equivalent to the original, I need to divide by 10 million, which is 10 to the power of, was it 1, 2, 3, 4, 5, 6, 7. So negative 7. So when you divide by 10 million, you're effectively you're timesing by 10 to the power of negative 7. Remember, 10 to the power of negative 7 is the same as 1 over 10 to the power of 7, which is 1 over, like I said, 1/10 millionth. So I should be very careful how I say that, 1/10 millionth. Okay, I'll just write that over here too, that 10 to the power of negative 1 is effectively 1 over 10 to the power of 1, which is just 1 over 1/10. So when you multiply 2.31 by 1/10, you get back to that original number. Okay, very good. Just check scientific notation. Let's do again. This number here has got to be between a number 1 and 10. It is. That's what we want. And this one is also between 1 and 10. That's what we want. Okay, you have a go at some of the other ones and check your answers in the textbook.